Let me start with a very simple question. Why does the universe allow things to be counted? Think about it for a moment. You pick up 2 apples from a table, you eat one, and one remains. You didn't invent that result. You didn't vote on it. You didn't negotiate with reality. One simply remains. But why? Why should the universe obey something as simple as arithmetic? Now imagine something even stranger. Imagine humans never existed. No language, no books, no teachers, no numbers written anywhere. Would 2 rocks still become 1 rock if one rolled away? Of course they would. And that's where the mystery begins. Because suddenly we realize something unsettling and beautiful at the same time. Numbers might not be something we invented. They might be something we discovered. Take a walk outside for a moment in your mind. Look at the branches of a tree. Notice how they split and split again into smaller branches. Look at a sunflower and see the spirals of seeds arranged in perfect patterns. Look at a snowflake under a microscope, delicate symmetry repeating in 6 directions. Nobody taught the snowflake geometry, nobody explained patterns to the sunflower, yet there they are, following mathematical rules, as if the universe itself understands numbers. And that leads to a strange possibility. What if mathematics is not a human language at all? What if it's the universe's language, and we simply learned how to read it? Now let's slow down and explore that idea together. Imagine you discover a cave deep in a mountain. Inside the cave you find ancient paintings on the walls, symbols and shapes clearly created long before you arrived. You didn't create those drawings. You discovered them. Mathematics may be like that cave. The truths of mathematics might already exist somewhere in reality, waiting for minds capable of recognizing them. For example, take a circle, not a drawn circle on paper. That's imperfect. But the idea of a perfect circle, a shape where every point along the edge is exactly the same distance from the center. Have you ever seen a perfect circle in nature? Not really. Everything physical has tiny imperfections. Yet the concept of a perfect circle feels completely real to us. Strangely real. More real in some sense than the imperfect circles we draw. So where does that perfect circle exist? Not in nature, not in ink, not in chalk. It exists in a realm of pure ideas, a realm of mathematics. And here's the strange part. Once you understand the idea of a circle, its properties are not negotiable. The ratio of a circle's circumference to its diameter will always be the same number. Always. That number is pi. 3.14159. An endless number that continues forever without repeating. No one invented pi. Humans discovered it. And it existed long before the first human mind ever wondered about circles. In fact, even if humanity disappeared tomorrow, the ratio would remain exactly the same. The universe seems to contain mathematical truths that exist whether we notice them or not. Now let's zoom out. Think about the motion of planets. The Earth moves around the Sun in a precise pattern. Gravity pulls objects together with perfect consistency. Light travels at an exact speed through empty space. These are not rough approximations. They are exact relationships that can be written using mathematics. The more carefully we study the universe, the more we find that everything obeys hidden numerical rules. It's almost as if reality itself runs on mathematics, the way a computer runs on code. But that raises an uncomfortable question. If the universe runs on mathematics, where did that mathematics come from? Did the universe invent it? Or was mathematics already there, waiting for the universe to express it? Imagine music for a moment. Before anyone wrote a symphony, the relationships between musical notes already existed. An octave always doubles the frequency of a note. Harmony always follows mathematical ratios. Those relationships were built into the structure of sound itself, long before the first musician discovered them. Music didn't invent those ratios. Music revealed them. In the same way, perhaps science doesn't invent the laws of the universe. Perhaps science simply discovers them. But here is where the mystery deepens. Mathematics doesn't just describe the universe. It predicts things we haven't even seen yet. Imagine writing down a few symbols on paper, performing logical steps, and suddenly discovering a new kind of star, a new particle, or a new phenomenon that no one has ever observed. Then years later, someone builds an experiment, and the universe behaves exactly the way the mathematics predicted. This has happened again and again throughout history. Equations written by human minds somehow match the behavior of the cosmos. Not approximately. Exactly. It's almost unsettling, because it suggests the universe and mathematics are deeply connected in a way we barely understand. Let me give you a simple analogy. Imagine you are watching a chess game between two grandmasters. At first it looks chaotic, pieces moving everywhere. But if you understand the rules of chess, you begin to see patterns, strategies, possibilities. The entire game unfolds according to invisible rules. The universe might be similar. On the surface it looks random. Stars explode, particles collide, galaxies spin, but underneath it all, the rules are mathematical. Now here's the part that always gives me chills. These rules existed before anyone understood them. The orbit of Earth around the Sun followed precise mathematical relationships, billions of years before any creature on this planet could count. The geometry of crystals formed inside rocks, long before mathematics was taught in schools. Even the earliest atoms followed strict numerical rules as they bonded into molecules. Reality was doing mathematics long before we arrived, and that suggests something extraordinary. Perhaps mathematics is not something inside our minds. Perhaps our minds are glimpsing something that exists outside us, something timeless, something universal. Think about prime numbers, numbers that can only be divided by 1 and themselves. 2, 3, 5, 7, 11, 13. At first they seem random, but they are not. They follow mysterious patterns mathematicians are still trying to understand. Those patterns were true before humans existed. They will still be true if humanity disappears. Prime numbers don't care about us. They simply exist, like mountains in a vast landscape of mathematics. And every mathematician is like an explorer walking through that landscape, discovering hills, rivers, and valleys that were always there. Not inventing them, discovering them. This idea can change the way you see reality, because if mathematics exists independently of humans, then something profound is happening when we understand it. Our brains, small collections of neurons inside our skulls, are somehow able to connect with eternal mathematical truths. How is that possible? Why should the human mind be able to understand the language of the universe? Why should logic inside our brains match the structure of reality outside our brains? It's one of the deepest mysteries we know, and the more we learn, the stranger it becomes. Patterns appear everywhere, spirals in galaxies, symmetry in crystals, rhythms in biology. Even the growth of plants often follows mathematical sequences. Take the famous Fibonacci pattern. 1, 1, 2, 3, 5, 8, 13. Each number is the sum of the two before it. This sequence appears in pine cones, pineapples, sunflowers, hurricanes, and even spiral galaxies. Nature seems to favor mathematical beauty, not sometimes, constantly, as if the universe prefers elegant solutions. But why should beauty and mathematics be connected at all? Why should the laws of physics be elegant? Why not messy? Why not chaotic? Instead, the deeper we look, the simpler and more beautiful the rules become, and that is deeply mysterious, because beauty is something we experience emotionally, yet the universe seems to share that sense of beauty through mathematics. It's almost as if the universe is whispering patterns, and our minds are capable of hearing them. But here is where the mystery becomes even more profound. If mathematics exists outside us, if the universe follows mathematical rules, then a question naturally appears. Is the universe merely using mathematics, or is the universe itself made of mathematics? This idea might sound strange at first, but think about it carefully. Everything we measure in reality, distance, time, energy, motion, can be described using numbers. Physics doesn't describe objects. Physics describes relationships between numbers. Space becomes geometry. Motion becomes equations. Energy becomes numerical relationships. Reality starts to look less like solid objects and more like a vast mathematical structure. And that thought opens a door to an even deeper question, a question we will explore next. If the universe is deeply mathematical, why does consciousness exist inside it? Why are there minds capable of understanding the mathematics of reality? Why should a universe built on numbers produce beings capable of discovering those numbers? It almost feels like the universe is becoming aware of its own structure through us. But that idea leads to mysteries even deeper than mathematics. Because the more we explore the mathematical nature of reality, the more we begin to question what reality actually is. And in the next part of this journey, we are going to explore something even more mind-bending. The possibility that the universe is not just described by mathematics, but that reality itself may literally be mathematics in physical form. And if that's true, then everything you see, every star, every atom, even your own thoughts, may be part of a vast mathematical structure stretching far beyond anything we can imagine. But if that is the case, one final question begins to emerge. A question so strange it almost feels impossible. If mathematics existed before humans, and the universe itself is mathematical, then who or what wrote the mathematics of reality? And perhaps even more mysterious, why are we able to understand it at all? So let's continue from that unsettling question. If mathematics existed before humans, and if the universe itself seems to follow mathematical rules with astonishing precision, then maybe mathematics isn't just describing reality. Maybe it is reality. That idea sounds strange at first, almost uncomfortable, because most of us think of mathematics as something that lives in textbooks or classrooms, symbols written on paper, formulas memorized for exams. But what if those symbols are only shadows of something deeper? What if mathematics is not something humans created, but something the universe is built from? Imagine for a moment that reality is like a gigantic invisible architecture, a vast structure stretching beyond space and time, every particle, every star, every galaxy occupying a specific place within that structure, and the blueprint of that structure is mathematics. Think about a spider web. When sunlight hits it just right, you suddenly see the geometry, delicate lines forming perfect angles and patterns. But the web existed long before the sunlight revealed it. In the same way, mathematics might be the hidden web of reality. Science is simply the sunlight that slowly reveals it. The more carefully we observe the universe, the more mathematical it appears. Take space itself. We often imagine space as empty nothingness, just a background where objects float around. But modern physics suggests something very different. Space has structure, space bends, space stretches, space can ripple like a pond when massive objects move through it, and those ripples, sometimes called gravitational waves, travel across the universe according to precise mathematical laws. So even emptiness behaves mathematically. Time behaves mathematically too. Clocks tick forward in measurable intervals. Particles decay according to exact probabilities. The expansion of the universe itself follows equations that describe how space grows over billions of years. Everywhere we look, numbers appear. But here is where things start to feel truly mysterious, because mathematics doesn't just describe what we see, it predicts things we cannot yet see. Imagine discovering a new island by studying the currents of the ocean. You never set foot on the island, but the mathematics of the waves tells you something must be there. And years later, explorers arrive and find the island exactly where the mathematics predicted. This has happened repeatedly in science. Entire phenomena have been discovered first through equations and only later confirmed by observation. It's as if the universe is quietly following a script written in mathematical language. But then another strange question appears. Why should the universe obey mathematics so perfectly? Why should reality care about elegant equations? Why should the laws of nature be simple enough for the human mind to understand? There is no obvious reason for this. The universe could have been chaotic beyond comprehension. The rules of physics could have been messy, inconsistent, impossible to calculate. Yet instead we find something astonishing. The deeper we go into the laws of nature, the simpler and more elegant they become. It's almost as if the universe prefers beauty, and mathematicians often talk about this strange phenomenon. When an equation is beautiful, symmetrical, simple, balanced, it often turns out to describe something real. Why should beauty predict truth? Why should elegance reveal reality? No one really knows, but the pattern appears again and again. Now let's take a step even deeper, because if reality is mathematical at its core, then everything in existence must somehow be part of a mathematical structure, not just planets and stars, but atoms, particles, energy, even information. At the smallest scales of the universe, reality behaves in ways that feel almost abstract. Particles are not tiny solid balls. Instead, they behave more like patterns of probability, mathematical possibilities that become real when interactions occur. Imagine throwing a pebble into a pond. Ripples spread outward in perfect circles. Now imagine those ripples are not water, but reality itself. Particles may simply be ripples in deeper mathematical fields. They are not objects in the traditional sense. They are patterns, and patterns are mathematics. But if that is true, something incredible follows, because it means the entire universe may be a vast network of mathematical relationships. everything connected through numerical structure, distances, energies, probabilities, symmetries, all woven together into a cosmic mathematical tapestry, and we are inside that tapestry. Now pause for a moment. Look at your own hands. Inside your body are trillions of atoms, each atom obeying precise mathematical rules, electrons orbiting in patterns determined by quantum mathematics, chemical bonds forming according to geometric constraints, your heartbeat following rhythmic timing, your brain firing electrical signals governed by physics. Your very existence is built on layers of mathematical structure. Yet somehow, inside this mathematical universe, consciousness emerges. You are not just part of the structure, you are aware of it. You can think about numbers, you can imagine infinity, you can discover mathematical truths that exist beyond the physical world. That alone is astonishing, because it means a universe built on mathematics has produced creatures capable of understanding mathematics, almost like the universe has become aware of its own blueprint. But here's where things become even more mysterious. The human mind seems capable of understanding mathematical truths that extend far beyond the physical world. Consider infinity. There is no physical object that represents infinity. You cannot hold infinity in your hand. You cannot measure it. Yet your mind can grasp the idea. You understand that numbers go on forever. 1, 2, 3, 4. There is always another number. And mathematicians have even discovered that there are different sizes of infinity. Some infinities are larger than others. That idea sounds impossible at first, but mathematically it is perfectly consistent, and once discovered it cannot be undone. It becomes an eternal truth. That's the strange thing about mathematical discoveries. Once something is proven mathematically, it is true forever. It doesn't depend on time, it doesn't depend on location, it doesn't depend on humans. A mathematical truth discovered today would still be true in another galaxy a billion years from now. This suggests mathematics exists in a realm beyond physical reality, a realm of pure structure, pure relationships, pure logic, and our minds somehow have access to it, which brings us to one of the deepest mysteries of all. Why? Why should biological brains made of atoms and chemistry be capable of understanding eternal mathematical truths? Why should evolution produce minds capable of exploring infinite logical worlds? Survival alone doesn't require that. Early humans only needed basic counting to survive. Yet the human mind can explore higher dimensions, abstract geometry and infinite structures. It's as if our intelligence has access to something far larger than our immediate environment, almost like a window into the deeper structure of reality. Now imagine something breathtaking. If mathematics truly exists independently of humans, then every mathematical truth already exists. Every theorem, every equation, every structure, even the ones we haven't discovered yet. Somewhere in the vast landscape of mathematics, there may be truths more profound than anything we currently know, entire worlds of logic waiting to be explored, and humanity is only at the beginning of that exploration. Think about how far we've come in just a few thousand years, from counting stones to mapping the expansion of the universe, from simple geometry to exploring the mathematics of black holes. What will we discover in another 1,000 years? What patterns remain hidden in the mathematical fabric of reality? What structures exist that we cannot yet imagine? Perhaps there are entire layers of mathematics that describe realities beyond our universe. Perhaps the cosmos itself is only one expression of a much larger mathematical structure. We simply don't know. And maybe that mystery is the most beautiful part of all, because it reminds us that the universe is not finished revealing itself. There are still secrets hidden in the numbers, still patterns waiting to be discovered, still questions that stretch the limits of human imagination. And the most remarkable thing is this: we get to participate in that discovery. Each time someone uncovers a new mathematical truth, they are not inventing something new, they are uncovering something eternal, a piece of reality that was always there, waiting, quietly, patiently, for a mind curious enough to find it. And that leads us back to the question we started with. Do numbers exist because humans invented them, or did numbers exist long before we arrived, embedded in the structure of reality itself? If the universe runs on mathematics, if nature follows elegant equations, if our minds can discover eternal truths, then perhaps numbers were never ours to create. Perhaps they were always there, hidden in the stars, hidden in atoms, hidden in the geometry of space and time. And perhaps the greatest discovery humanity is making, step by step, equation by equation, is not just about the universe. Perhaps it is about the deep connection between mind and reality, because somehow, in a universe made of mathematics, tiny conscious beings emerged, capable of understanding it, and that might be the most mysterious equation of all. So the next time you see a spiral in a shell, a pattern in a snowflake, or the silent motion of the stars across the night sky, remember this possibility. Those patterns were not invented. They were always there. The universe has been speaking the language of mathematics since the beginning of time, and only recently have we begun to listen. But the final question remains: if mathematics truly is the fabric of reality, then what deeper truths are still waiting in that infinite mathematical universe for the next curious mind to discover?